Well, hello everyone. Uh, I had some problems with my screencast sync. Oh, and round was postponed. So cool. I thought like I will start uh, 6 minutes after the start of round, but looks like it's not the case. Well, let's hope that everything will work fine during this screencast. In case it's your first time on my channel, I will try to solve Cat versus Round, second division, and I will try to explain what I'm doing. While we are waiting for the start, you can see that I was trying to solve some very strange problem where you have to draw this fractal using ASCII art, and this is insane. It's like it's not given in the statement how you should draw the stuff. It says just use this slashes, backslashes, and underscores. Like it's not true that this picture is somehow representing the real fractal, because like you can say that we somehow choose a coordinate system and we are always staying in lotus points, but that's not true on this picture and in samples also. Like this thing, this should be 1 point, but actually it's not on this picture. And they didn't get accepted, so this picture looks exactly like the output from the samples. I don't know. Okay, so we have three persons on a line, the endpoints A, B, and C. We have to move them somehow. The score is sum of distances we move, and we want to move them in such a way that pairwise distances between them at least d. Well, it's obvious that they shouldn't change their relative order, so we will sort these three numbers, and from left to right they will be in this order. And it doesn't make sense to move the middle person because like we have to make two distances between leftmost and middle and rightmost. We have to make at least d. We can increase by one no more than one of these values each time, and if we move leftmost, we just increase left distance by one. So we just take these two distances, and if we have to increase it to get at least d, we will add the difference between d and this distance to answer. I don't know why, but each time when I have to sort three number, I do it this way. It's like bubble sort, but by hand. So we have some broken keyboard. When we press a button, it prints at least once, maybe more than once. Okay, so we have some independent queries. We have to check if the second word in pair can be printed when we use given keystrokes and our not very good keyboard. So we just have to look at groups of consecutive equal letters and check that these groups inside, like the letters are the same, and in the second word there are more letters than the first one, not less. I want to do like the real groups. We can do everything on the fly. So now I'm finding these groups of equal characters. If the group is different, then it's bad. If in the first word there are more letters in the same group, then it's also bad, and we have to move to the next group. And the second word have to be finished. This whole job. So it says that there's an exam and the student takes random random ticket. It can be either easy or hard. If it's hard, student go home, and if it's easy, it takes some fixed amount of time for him to answer. Students are in some fixed order, and we have also some time for all students, and we have to answer for each student how many students before him should fail for him to succeed. Like he has to answer his ticket in time. So obviously, like we have some independent problems, like they are on the same data, and we will use that. But like how to solve this version, which have lower constraints? I suppose it's like 10 to the fifth or 10 to the sixth here. 10 to the fifth, and m is big also. Okay. Obviously, we want minimal number of students to fail, so we want to fail students that take most time. So like we are only interested in we will have students in order of decreasing of their time, and we want so that all the remaining students plus our time be less than or equal to m, and times are not more than 100 in hardware version also, and I think we can use that. We can just calculate the number of students with each time, and then emulate our choice in time proportional to 100. We will take students with times from smaller to greater. For each time we will know the number of students currently with the time, and we can calculate maximum number of students that can pass the exam in like 100 iterations, and it should be enough. We can answer everything online, like don't remember the numbers. So now we will calculate the answer, and afterwards we should remember that we have one more student with time x. So now what we want. Current sum is x because we have to pass the exam, and we want to take as much as possible students such that sum is still less than m. We have I students before us, and the students we are allowed to pass will be subtract from the answer. How many students we can take? We cannot take more than let's say that it's the sum is how many time left. We can take more than left divided by y, and also we can take more than we have students with time y minus z, and we have less time left by how many? By y times z. Let's move to the next problem, and when this will be accepted, I will submit C2. So we are given some array of numbers. We have to delete exactly one of them, such that we can reorder all remaining numbers, and they will be an arithmetic sequence. Well, I think it's kind of easy. We can sort everything from the beginning. Then what will happen? We will remove one number from the sorted sequence, and the differences between consecutive elements should be all equal. So what we can do? We can calculate all the differences beforehand, and then when we remove one element, we remove two differences. Well, if it wasn't the first or the last element, and add one new difference. After all this after all these actions, we should check if all the differences are exactly the same. Okay, so we can do something very stupid. We'll just store in map how many differences we have for each element. Like for each difference, how many times we encountered it, and then we will just check if the size of map is exactly one. Not exactly one, no more than one. We will have function that adds number, like adds y to number x in map, and if this number becomes 0, it deletes the element from map. Add all existing differences, and then we just try to remove each element. There are some corner cases here on the border. So in this case, we just remove one difference. Also in this case. And in this case, we remove two differences and add one. It's not the best solution, but I guess it has very bad constant factor, but I hope it will be enough. the size if the size is no more than 1, then our element is good, and we can print its ID and exit, and then we should return everything to the previous state just by adding everything backwards. So we have some rectangular piece of paper. And we draw no more than 26 lines on this piece of paper. In each line we denote by lowercase Latin letter. We draw them in order A, B, C, and so on up to that. We are given a piece of paper on which everything are already drawn, and we are asked to find if this picture can be this drawing described in the statement, and also we can override some places. So what will we do? I guess it will be okay to solve everything in times proportional to size of input multiplied by the size of the alphabet. So what will we do? We will work backwards. First we can understand what was the last segment we draw, because it wasn't covered by any later segments, because there are no later segments. So the latest letter we have on this drawing was the latest segment. Then we will do next thing. So we want to find the possible position of the segment. If it's not the segment, we just say that the answer is impossible. How to check that? We will just find the upper left and down right corners if the height and width of this rectangle is more than one, then everything's bad, and otherwise we will just check by hand that it can be a segment. We have other letters, yes, but what we will do, we will after drawing like the latest segment, for example, we will change each cell with of the segment to like a question mark or something. It means that we can draw over this cell and everything will be fine, because we will draw over it afterwards. So to check that segment can really be drawn using this letter, everything in the segment should be either this letter or question mark. Otherwise, we just say the answer is no. And also, it can happen that there are no letters left. Like we can draw a segment of size 1 and then the segment of size 1 over it, and it will be just B. I don't know if there are some samples like this. We can draw something using A and then B and C, and we don't see any A. In this case, we will just say that this letter was the segment was just the same as the last one. It will cover it exactly, and everything will be fine. Okay, will be the number of segments used. So here we will for each letter remember it's upper left and down right. Symbols. Yeah, it will be just the uppermost, the downmost, the leftmost, and the rightmost. I guess it will be easier if solve will return bool. Just that we can like return false anywhere if something breaks, and we'll catch it here. If not false, we'll just print no here. It's no good. If the answer is yes, the solve will print the answer, since we have to restore the actual segment. Well, not the actual segments, some segments. Okay, so now I want to find the biggest symbol that was on the sheet of paper. That means that a sheet of paper is empty and it's fine. I think we are allowed to use zeros next segments. This means that we have some rectangle is heightened with more than 1 and it is bad. Okay, otherwise we can check all the things. I forgot. It can happen that we don't have any letters left of this kind. This is insane. We know that we have k-1, otherwise we will not stop here. And we can just okay, I'm working backwards, so I have to store answer somewhere and then print it. And also anything bad can happen, so we have to store it. Anyway, so we will just use exactly the same thing as the largest letter, which has ID k-1. Okay. We want to check that everything's fine. What can go wrong? So it's good if this is our letter, or if it is question mark. Otherwise, it is bad. And we will change it to question mark because we will paint this segment. Maybe I don't trim hands, but I failed somewhere. Let's see. I failed in the largest slot. That's interesting. Oh, it should be and here. Well, this is insane. I think I'm printing something wrong. How can it? Oh, okay. In the wrong order. Plus one everywhere. Okay. Just oh, I forgot. It's a note now. Because I should do continuous here. Okay. Wrong time. Oh. This is a rectangle, not square. Yes, can do some. Okay, so we have some masks of size 9. We have some N masks. Interesting. And M masks, from which we have to choose exactly 2. Each of these masks have its cost, and we want to choose these 2 masks in such a way that as much as possible from the first class of masks are a sub-mask of the masks, of at least one of the masks we choose. So the size is 9, so we can try all the 2 to the 9 square possibilities. I don't understand what's the problem. So we have to calculate some sums on this, but it also can be done in some stupid way. But not actually interesting. So is pretest passed. Okay, I don't understand this problem. We just have to do it first search. Why? This is not okay. For each mask we only need 2 cheapest pizzas, because obviously. So we remembered two best pieces for each mask. What we have to do next? We have to, for each mask, we have to calculate the number of interest masks which are submasks. It's a standard dynamic programming, but can do easier. And this dynamic programming is actually like prefix sums on 9 dimensions. We can choose two equal pieces and we have to choose this, not nothing. So the number of masks which are submasks of at least one of ours, 2 is the number of submasks of first plus the number of submasks of second minus the number of submasks of both, but it's exactly the number of submasks of the So we want to maximize the number of good masks and then minimize the cost. So we'll make like this. Get the second, so we can just use this. Ah, okay, cool. I don't think that it's change anything, but this statement is garbage. Like, okay, the or of uh, these two should. Okay, cool. Very interesting problem. Overcomes. Okay, we have some and songs. Mm, every song has a genre, and there are only three of them. And each song has a duration, integer from 1 to 15. We want to count uh, the number of uh, arrays of the songs such that no song is repeated. The total duration is exactly big T, and no two consecutive songs have the same genre. There is a harder version with interesting limitations. So the easy version is, I don't know, just it looks like okay, it's submask GP, but okay, it's easy, not interesting. Let's solve the harder one. So we still have only three genres, and now we have to come up with some polynomial solution, probably. So the lengths are up to 50, and the number of songs is also up to 50. Well, I guess we can calculate uh, the sets of songs. What's interesting, like total duration, obviously, and the number of songs of each genre. Then we will place them in some order, and we have to count the number of good orders for each set. Uh, like obviously, it has to have correct total duration, but we also have to use correct ordering. So I guess it counts the number of correct orderings for all triplets of number of songs of given genre. We can use another GP, and the solution works in what time? How many states we have? The prefix of songs, total duration, and the number of songs of each genre. Yes, it looks like it's n to the fourth multiplied by t, but actually, like, yes, but it's divided by 27, and I think it's okay. Divided by 27 because it's like product of the number of songs of each genre. The sum is 50, so the maximum value we can get is 50 divided by 3 in cube. So how many is that? It's something around 6 multiplied by 10 to the 8. Well, it's not clear if it's enough. We can calculate this DP for first and second genre, and independently just for third, and then since we know exactly what duration we want, we can brute force over how many songs there will be from third genre and its total duration, and how many songs there will be from first, and how many songs there will be from each of the genres, and total duration of songs for third genre. Okay, this have good complexity, and it works very, very, very fast, I think. Well, it has multiplications of long longs, which is not very good on code forces. But okay. we need DP for songs from first and second genre. It will be number of songs. So first genre, second, and total duration. It's a lot of memory. It's much less actually, but oh, okay. Let's write very good solution. We can choose first and second genre to be the smallest and second smallest base number of songs. Then it will be no more than n divided by 3 the smallest, and no more than n divided by 2 the second smallest. This is so small, but okay. We need the same DP, but only for the third genre. And we also need DP for how many orders there is for given number of songs in each genre, and the last parameter is the last song. We need it because we have to ensure that every 2 consecutive songs are different. Okay, let's go. We can calculate DP3 not using anything. when we already calculate this DP, like when we will use it, we don't have to know the last sum. We only need the sum of over all three genres. Okay. Okay, now it's time to calculate GP1 and GP2. So we can take the song and not take the song. Almost the same for A1. Just need to do +1 here. And something similar for GP2. Maybe it will be actually easier to rewrite from scratch, but I don't know. So what's now? Now we will try all the variants for number of songs for each genre. And total duration of all songs from third genre. So what are the values we need? From GP1 it's y the minus q, and from GP2 it's z q. And we also have to multiply this by c xyz. I guess I didn't initialize something here. It's incorrect. Cool. Well, obviously we have to take all three songs. Well, that's interesting. There is only one and it's correct, and so what's incorrect is C. That's interesting. So the mistake is somewhere here. Oh yeah, I added this value. Look, we can comment it, and it will probably work. Yep. Like the correct answer. Okay, we can do that. We don't need it actually because we have to include at least one song because big T is at least one. Well, but correct value is one, and I made here just like just for this to be true, but I actually did transitions from the state which is not correct. I already made them in the initialization. Okay. Let's take one more look. All zeros. That's interesting. In input it says that it's all the songs are out. No. So we have one song from genre 3 and two songs from genre 1. Well, actually it will be one song from genre 2 and two songs from genre 3 because I sorted them. And yes, we can see that. But for some reasons it's zeros. copy paste is not good. Children. But oh yeah, I'm saying that all the songs from genre 1, for example, are the same. That's not true. We should multiply by some factorials when we calculate C's. Let's calculate factorials. How's the problem of 77? It's easier than E. Well, no, G is also. I think this contest is easier than the last Division 3 contest. Well, problem G is fine. I think that my very smart things wasn't necessary for getting accepted. It's 5 seconds. Multiplying by 20 won't too bad. I did okay-ish. Interesting. Well, I guess some of these guys will overcome me. But that's fine. Thanks for watching.